Hey guys, welcome to another video by Supernal Tutorials. In this video we'll be looking at physical sciences. We're looking at the concept of mechanics. So in this question we're gonna actually answer a question, right? So we told that two blocks of mass m kg. So this m actually means that it's a variable, it can be any mass, right? And 2.5 kg respectively are connected by a light inextensible string. So this just means that the string does not stretch, the force is maintained throughout the entire string, and that the string runs over a light frictionless pulley. So that just means that the pulley does not exert any force on the string. So the force is maintained throughout the string, and that force is tension, right? And then we also told that the blocks are stationary. Okay, so yeah, this is our diagram right here. We have two masses connected by a string. So, and we also told that the blocks are stationary. So it means that the forces balance out within the string. Okay, so let's look at our first question. We're told to state Newton's third law in words. Okay, so this is just a theoretical question. This one you can actually memorize over time, yeah. But yeah, in application you can actually even understand it, and you wouldn't have to memorize, but it would come as you understand it. Okay, so we're gonna state it like this. When object A exerts a force on object B, right? Object B exerts the same force on object A. So the force is of equal magnitude, but in a different direction. So this statement just means that when two objects are actually interacting, right, the force that one object exerts on the other object is actually going to be equal on both the two objects, but they'll be opposing in terms of direction. Okay, that's all for the first question. So for our second question, we asked to calculate the tension in the string. So guys, what you need to always notice is that they always lead you on. So when they actually put a diagram and a statement right there, you need to know that everything links on, right, as you follow through with the questions, right? So in the first question, we were asked to state the Newton's third law in words, right? So the law actually talks about what two objects interacting, right? So this is actually the case right here in this question, right? Because this string connects the two mass blocks, right? It connects them, so it's simply an interaction of two objects. And then by Newton's third law, we told that the force that object, for example, this object right here, right? The force that this object right here exerts right along the string, right? It's gonna be the same as the force that this block will exert on the string. So it's simply a case of opposing forces, right? So if we look at this mass piece right here, we know that we're gonna have a weight, right? So, and since we told that the blocks are stationary, it means that they are not moving, right? So if we consider Newton's third law, it actually operates on this equation, right? So since we told that the blocks are stationary, it means that our acceleration is 0, right? So we have F net is equals to what? 0. But when you consider this, is that we have weight going down, right? So when this block creates weight going down, it stretches it causes a force to be created within the string, right? So this force that is created within the string is tension. So this force actually what counteracts what the weight, and it's due to this mass piece at the other end. So we're gonna have tension going right up. So remember, F net is what is the sum of forces, right? Whereby we also consider the directions, right? So since the two forces right here oppose each other, we can actually subtract them to actually get our F net. So call tension T, right? And then minus W for weight is equals to 0. So this simply means that since what the blocks are stationary, our tension will be equals to weight. So the tension will be equals to mg. Weight is equals to mg, right? And then m is the mass, which is 2.5, and then g, which is 9.8. Punch this into the calculator, you'll find out that T is equals to 24.5 newtons. So yeah, you have actually determined the tension in the block. That's all for the second question. For our third question, we told that the coefficient of static friction is 0.2. And then we also asked to calculate the minimum value of m that will prevent the blocks from moving. So we still told that the blocks don't move, right? And then you notice that from our previous question, we had that the tension in the wire was 24.5 newtons. And then this question still tells us that the blocks are not moving, right? So we're still going on with that condition. And then we now have factored in the friction, which is the friction that will exist between this block right here and the table, right? Yeah. So that means that remember, using Newton's third law, right? We told that when object A exerts a force on object B will exert the same force, but just in a different direction. So since we know that there is tension right here in the Y, and then this tension exerts a force of 24.5 newtons, that means that this block also experiences that force, right? And then we also told that there is static friction. So this means that the static friction, the force caused by the static friction is equals to the tension in the Y. And as you can notice, there is no other force you can actually consider for this question. So the static friction force, sorry about that, is equals to the tension in the Y. And as you know, from the formula of the static friction, it's going to be mu times n is equals to 24.5 newtons. We have that value right there, so So the normal force will be 24.5 over 0.2. Let me quickly calculate this. So when you punch this in the calculator, you'll find out that normal force is equals to 122.5 newtons, right? And then, as you know, the normal force is a force that acts normal to the block, and the normal is equals to mg, right? Remember, we're considering this block right here because this is where the static friction occurs, right? And the normal is equals to mg, right? And then we're going to substitute in the value of the normal, and then m is what we're looking for, right? So when you switch this around, you'll find out that the value of the mass that will allow the static friction to be equals to the tension that's maintaining stationary, with the system to be stationary. So the mass is 12.5 kg. This is the mass that will allow the system to remain stationary. I hope that makes sense. That's all for the third question. For our fourth question, we're told that mkg block is replaced with 5 kg block, and then the 2,5 block now accelerates downwards, and the coefficient of kinetic friction is 0,15. And then we told that we need to calculate the magnitude of the acceleration of the 5 kg block. Okay, so from the statement, we told that the 2,5 block accelerates downwards, right? And then we need to calculate the magnitude of the acceleration of the block. So to analyze this question, we actually need to look at the blocks individually, and we're gonna do it like this. So let's consider okay, let's start with that block right there. So for the 5 kg block, we're gonna do it like this, right? We told that there's kinetic friction. Now this means it's a different scenario. The system is no longer stationary, now it is moving. So we told that acceleration, this block accelerates downwards. When this block accelerates downwards, it means that this 5 kg block is moving to the right, and then there's kinetic friction which opposes the motion of this 5 kg block, which goes to the left. So if you consider the entire system, right? Okay, let's put in the Newton's third law equation. It's going to be like this, right? So we told that this accelerates downwards, causing this to move to the right, and the kinetic friction opposes the motion. But ultimately, this 5 kg block does move. It then means that the force right here within the wire, it is very great compared to the kinetic friction. Therefore, when we substitute right here into the force summation, the F net, it's going to be tension minus friction, not the other way around. Remember, tension gives us the greater value. It's equals to MA. M is the mass of the block that we're considering, so it's going to be 5. And then we actually have everything we need to calculate the kinetic friction. Okay, so let me rearrange this. It's going to be T is equals to 5A plus mu Km. So So this is 5a plus, we're given mu k, which is the coefficient of kinetic friction, right? And then we have that n right here. N, remember, it's mg, so it's going to be the mass, which is 5 because we're dealing with the 5 kg block, times gravitational acceleration. So this is going to be T is equals to 5a plus 7.35. This is the answer you get when you punch into the calculator. Okay, so this gives us our first equation. So for our second part of the question, we're going to consider the 2,5 block. So remember, the statement says that this block accelerates downwards, and this is due to the weight. So that means there's weight right here in this block, and the force is going downwards. And then there is another force, which is the force in the string, which is going to be tension. And then now you need to write down the Newton's third law equation. It's going to be like this. And then we need to determine F net. So you need to put it in the right way. Remember, it's accelerating downwards. That means that the weight is greater than what? The tension. So it's going to be weight minus the tension is equals to m. M is the mass, so 2,5a. This is very important, right? The determining which one should come first, because if you put it in the wrong way, then it means that you're saying that we're gonna have, remember, since I'm saying the weight is greater than the tension, that means we're gonna get a positive value. But if you put the tension over there and the weight this side, then you're gonna have a negative value, and it wouldn't match with this side, because remember, our acceleration is positive in this case, because we're saying that the 2,5 block is accelerating downwards, so it's a positive acceleration. A negative value for acceleration would be a case of deceleration, but never mind that. So okay, the weight is mg, the mass is 2.5 times 9.8 minus t is equals to 2.58. Remember, t is actually the same since it's one string. So let's rearrange this. It's going to be t is equals to when you put this into the calculator, it's going to be 24.5 minus 2.5a, right? And then this is your second equation. Our first equation from the first part was 5a plus 7.35, right? This was the first equation, right? And as you can see, we have t and the t there, so it's going to be a simple case of equating the two equations. So the first equation is 5a plus 7.35 is equals to what? 24.5 minus 2.5a, right? So we're gonna take like terms. So 5a, when we take this to the other side, it's gonna be 5a plus 2.5a. This is gonna give us 7.5a, right? Then it's equals to, we have 24.5, right? When we take that 7.3 and we bring it to the other side, it's going to be 24.5 minus 7.3. This gives us what? When you put that into the calculator, you find that that gives us 17.15, right? Then you simply divide by 7.5. then you'll find out that your acceleration is 2.286. You can round this off to 2 decimal places. Always remember to put your units. So as you can see, the acceleration for the system is the same. The acceleration is the same for the 5 kg block, it's the same for the 2.5 kg block, because it is one connected system through the string. So this is all for this question. And now for our final question, which has absolutely nothing to do with the previous questions. We told that a small hypothetical planet X has a mass of 6.5 times 10 to the 20 kg and a radius of 550 kilometers, right? We asked to calculate the gravitational force that planet X exerts on a 90 kg rock on this planet's surface, right? So firstly, you need to know the equation of the gravitational force, and it is like this. Okay, so this is the gravitational constant, and it is like this. That's the constant. I'm not really sure about the units, but in this question it's actually a direct substitution kind of question. So this is the value for the gravitational constant, right? And then that is the we have, these are the masses, right? We can actually decide in whatever way you wish in terms of which one should be mass 1 and which one should be mass 2. So it really doesn't matter. I took the mass of planet X as mass 1, and then mass 2 I took the mass of the rock. So it's always 2 objects that we focus on, right? And then this is r, this is the distance between the 2 objects. So it's actually the distance between the centers of the 2 objects. So remember, we told that the radius of the planet is 550 kilometers. So the radius is 550 kilometers away, since the rock lies exactly on the planet's surface. So the distance between them would then be 550 kilometers. So as you can see, we have all the values as you can see on this equation to calculate the gravitational force. And since it's a force, the unit is newtons, and remember, it's actually a weight in a way. So let me just directly substitute. It's always good to actually keep your units constant, right? As you can see, I used as it was given, it's kilometers, kgs, and yeah, probably the constant as well as kgs somewhere right there to match up to the standard, which is going to give us an output of newtons. But here the constant is really simple. There isn't much to this question. It was actually a direct substitution. Remember the unit right here is what? It's meter. But as you can notice right here, we have what? A kilo. So we're going to say times 10 to the 3. Squared. So when you punch this into the calculator, you'll find out that the gravitational force is 12.90 newtons. Actually round this to 2 decimal places. So yeah, that's all for this video. Please comment, make recommendations on how we can actually improve, and please share.